Thank you very much. So, it's probably safe to assume. Closer. Okay. Right there. Right there. It's probably safe to assume that you're at this conference because you're on an API journey. Yeah. Whether you're building your first API or you've deployed numerous successful APIs, wherever you are on that journey, you're going to hit this question one day. And it's going to be, hey, we have this new feature that we want to deploy. Should we add it to an existing API, or should we create a new API? Really, really close? Oh my God. Duct tape. Right? Okay, I'll try that right there. So it may sound like a decision that has little importance, but as your API program, your API portfolio grows, the choices you make will have an avalanche of consequences. And interestingly, if you were in Ruben's talk yesterday about Solid and the decentralization of data, and it's probably worth mentioning that if that succeeds successfully, you can probably ignore a whole bunch of what I'm going to talk about for the next 40 minutes. But that's a big goal that he presented, so I think we're probably good. You'll probably still get some useful information for the next few years out of this talk. So adding a feature to an API makes it bigger. So how big should an API be? And sadly, there is no easy answer to this question. It's kind of like asking, well, how long should a piece of string be? But let's start with a more fundamental question. What is an API? Or to be more precise, what is an HTTP API? What are the boundaries? Where does it start? Where does it end? So I have this definition. An API is a set of resources that have a common base URL. And the flexibility of this definition is one of its strengths and weaknesses, and we'll come back to why this definition is kind of handy a little bit later on. But first, I want to clarify what this talk is not about. API Platform provides you with the tools to build successful APIs. This conference is packed with sessions teaching you all about API Platform, and there's lots of people to teach you about it. I'm not that person. I believe I can help you design APIs that can be built with API Platform. And I want to talk about how to design and shape those APIs so that you can continue being successful as your API surface grows. And if you're wondering how much is that API surface going to grow, consider these recent stats from a Gartner study. 80% of organizations either provide or are planning to provide public APIs, and that's up from 46% in 2019. And 94% are planning to consume APIs provided by third parties, and that's up from 52%. Those are massive growth numbers in the interest. And APIs are going to become the lifeblood of business interactions. And if you know how to build APIs, you're going to be busy over the next few years. But as your API surface grows and gets bigger, you're going to run into some growing pains. And how do I know that? Well, I spent the last 5 years working on what you could claim is one of the biggest API surface areas in the world, Microsoft Graph. If you have a Microsoft account, either for playing Xbox games or accessing that Hotmail account that nobody knows that you have, or you have an enterprise account for email, Teams, OneDrive file sharing, this API has all of that data available to you. And the Microsoft Graph API, technically it's not an API because it's really just a facade over APIs built by more than 70 different teams at Microsoft. And I say it's big. How big, right? Well, if you take the OpenAPI description and you serialize it to JSON, it's about 2 million lines of JSON. I really don't wish that on anybody, but it has forced us to address certain scale issues that do become apparent even before you come even close to this size of API. But why would we build this as one API instead of just building it as 70 different APIs with 70 different services? So, well, one kitten is cute, right? 10, a little bit more tricky to manage, right? So far in our industry, we have tended to scale out. when it comes to building APIs. We have more functionality, we ship a new API, but I think that is due to a limitation of our tooling and our design approach. And I don't think it is in the best interests of API consumers. Scaling out, it creates this opportunity for API silos to happen, and it's easier for inconsistencies to creep in between APIs built by different teams in your company. And it creates this kind of the Conway's law effect, where the shape of your software ends up looking like the shape of your organization. API success in an org breeds more APIs, either by other teams in the organization or your own team will be asked, hey, you did this awesome API, go build another API for us. And you build the API, and the APIs, you use that as a deployment, a unit of deployment. And so you make updates, and you ship that new API. And so it ends up with those APIs looking like your developer teams. And that might make sense if you're building APIs for your own products. But by definition, you're putting APIs out there for external consumers to be able to integrate and mash up and combine. And their needs and the shapes of the APIs that they need are not necessarily the same. Well, hopefully not the same as your own products, because then they'd be building competing products. So, but sometimes API producer teams will, yeah, but our needs are different than that other team over there that built an API. Our customers want something different. Well, maybe they do, or maybe it's just, that kind of we're a special snowflake type thing that sometimes those developers kind of, yes, we're different, we're special. But consumers, they crave consistency. McDonald's is not a global brand because they make awesome hamburgers. Consider the world of e-commerce. Many companies build their own websites with e-commerce engines, and you can go and you can buy Nespresso coffee from Nespresso. You can go and buy Adidas from the Adidas store. But online marketplaces like Amazon or Alibaba dominate the online sales industry. Customers don't really care about your organizational boundaries. They want consistency, convenience, familiarity. Experience has to be massively better to overcome consumers' resistance to learning something new when it comes to just getting stuff done or buying something. This is why there are so many aggregators in the API space, where companies say, hey, come use our aggregation service because we have all of these APIs behind, and we'll give you a consistent experience to access all of this stuff under the covers. So how do we take the APIs built by different teams within your org and make them appear like a consistent whole? So API federation is one solution. It's where it's often done with a gateway that hides all of the back-end APIs. But really, that's it's an implementation detail. What's more interesting, at least to me, is the design of the resource identifiers that make up this new coherent, consistent API. Is how do you take all these distinct APIs and make them appear as one? Well, we have universal resource identifiers, and these things that we use in HTTP APIs are capable of actually quite extraordinary things, and we really don't take advantage of that power as much as we really should. So here's a bit of a thought experiment. You remember the definition that I mentioned earlier about an API is a set of resources that share a common base URL? Well, according to the spec for the URIs, https:// is a base URL, which basically means every website and every API on the planet is effectively one API using that definition. And if you think about it, if you use a generic HTTP client, like Guzzle or Symfony client or Fetch in JavaScript, it's effectively what you're doing. You're accessing the entire web as one API with one set of resource identifiers across the entire web surface. But for the sake of our conversation, we're going to assume that we want to federate an API within our organization behind a single common authority, right? The domain name, port, commonly what a lot of people do, and one of the nice things about it is it allows you to share an auth token. And historically, getting an auth token is one of the worst parts of developer experience in accessing an API. And so if I can use the same auth token to access any API within or any resource within my entire organization, that's a win, right? And so then we can just focus on path structure. So let's say we have, resource-oriented API. I know all of you are familiar with this style of API. Let's just forget about the authority for a moment. This pattern of paths probably looks very familiar. We've got collections, things, items, and you possibly more accurately call this an entity-based or entity-oriented design. And this works great for small APIs. It gets a bit cumbersome when you have more. Microsoft Graph has thousands of entities. That ends up being a very long list. And you sitting in your IDE and you press dot, and this really long list appears, or you're trying to put it in documentation and you have this really long flat list. It kind of sucks. Becomes unwieldy. It's also a bit challenging if you're trying to model bounded context. And there are different perspectives on a customer, because salespeople think differently than customer support people. So one way we can manage that is we can go and introduce what I call an API category segment. I think I heard the term namespace as a way of calling this segment. It's where we can just kind of group resources together that all naturally live together. Now, using the API definition, I could say accounting is its own API because it all has a common base path. Or I can just say, no, it's all just one API. It kind of becomes relevant at that point. As long as I can find the resources that I care about, that's the important thing. And then you kind of get crossover. It might map to accounting might be a back-end team, or it might not be. Sales team manages customers, but the accounting team want to have tax information about those customers. So all of a sudden, the boundaries between these things that really matter to the consumer of the API and the back-end teams who are providing that information, that data storage, they kind of get blurred. But really, we should care about the consumers more. Now, there's other reasons that you might want to add segments at the beginning of the path. It's crazy how powerful by adding one single path segment to the beginning. I just changed my API from being a single company accounting product to a multi-company accounting product just by sticking a path segment there. If I've really made a bad job of my first API version and I want to throw all of it away and create a V2, I don't recommend it. You could put a version number in there. If you want to charge people and you want to have a license key, you could put it in there. You can put it in headers too, but it's possible to put it in the path segment. These are reasons for adding segments at the beginning of the path, but sometimes it's also useful to add segments at the end of the path. You can express related entities. I have an invoice that has a customer. Here's a path that goes and gets the customer of an invoice. I can go get the quote of an order. I can create views on collections. So instead of seeing the list of all of the customers, I want to just see the VIP customers. I can have collections that are related, so I can see all of the orders of a customer. You get the idea. There's a bunch of things. You can have actions if you can get over putting a verb in a URL, which I'm perfectly fine with, but you can put subscribe. So let me know if there's things that change in these parts and call a webhook. Not everything in that path needs to represent an entity. It can also represent other things that are useful. I mean, the definition of a resource in HTTP is like, represents something of interest to the application. It's spectacularly vague, the definition of what it is. The point that I'm trying to get across is just to reflect on the impact this simple list of path segments have on the capabilities of our API. And it's a powerful tool that we should spend time thinking on and building when building the API. And when it's used properly, you can convey a significant amount of meaning to the developers who are consuming the API, especially if you use these patterns consistently. And I started to collect together a list of, here's different reasons why people might use path segments. And I'm accumulating more of this stuff. I'm also doing it for query parameters and stuff like that. I have it up on my blog. But with these semantics, you can start to convey much more than just, it's not just a list of strings, a list of characters that make up a string. And to varying degrees, we all go through this process when designing the URLs in our API. It isn't always easy, but it does bring a better developer experience to our customers when we actually take the time to think about this. So let's talk a little bit more about developer experience. So I shamelessly stole this survey result from the Postman 2022 State of the API. And I'm pretty sure I could look at this graph for the last 5 years or as long as they've been doing it, and pretty much the top item on here is for always lack of documentation. 55% of respondents said documentation was an obstacle. Funny thing is, lack of documentation, it's not always what people mean. What they actually mean is, I couldn't find the documentation that we're looking for. We get this complaint all the time at Microsoft. Can't find it. Your documentation isn't very good for, I'm toning down my language. Your documentation isn't very good for this particular API. We couldn't find this. And it's like, well, it's there. Oh, I couldn't find it. And the reason is because we get told that we're lacking documentation. So what do? We write more documentation. And we get told that they don't like the documentation, so we write more documentation. Guess what? It makes it even harder to find the documentation because we just kept piling it on and putting more and more documentation. Sometimes, you saw earlier this morning about deleting code. Sometimes deleting documentation is a good idea too. The next item on the list is the difficulty in discovering APIs. And if you think of my really flexible definition of what is an API, it kind of, well, what do you mean, discovering APIs? And there's a number of reasons that finding APIs is hard, and we'll take a look at a bunch of examples on websites to kind of illustrate why that can be a problem. But fundamentally, the problem of finding APIs is hard because they're packaged arbitrarily based on the team that shipped them, and they're named by like the marketing team who may never have met an API in their life. So it's not quite so hard when you're talking to like a small company, like a Stripe. I call Stripe small company, but sorry, perspective when you spent too long at Microsoft. They're a company that we think of the company and we think of their API. So it's the API and the company are the same. And there's Twilio, or another great example. They're showcased as one of the great developer experiences in APIs. Or SendGrid was another example. Well, until Twilio acquired SendGrid, and now SendGrid are actually part of Twilio, and so now I have to go to Twilio to find the SendGrid API. So things change over time. Organizations change. It comes back to, if you name your APIs after parts of your organization and you do reorgs, then, what are we going to do with the API? Because changing APIs has a lot of consequences to the consumers of those APIs. So let's say that I have convinced you for a moment of the value of putting thought into designing beautifully, semantically meaningful, consistent paths to API resources. The next step is to communicate that beauty to your customers. So we need to give them documentation to understand how to call those APIs. We need client libraries to take away like all the boilerplate of dealing with serializing and authentication and rate limiting. And maybe even build interactive experiences to let them explore how to use the API and experiment with the API. All right? So let's build on the shoulder of giants and go look and see how other companies do this. Now, I've specifically selected examples where there are highlight some of the challenges as your APIs go. And I'm not showing these issues to say, look at what a bad job this company did. Like this stuff is hard and we need to learn from each other. And I want to make a case to say why those beautifully designed resource hierarchy needs to be front and center in those developer experiences, and it currently isn't. So I have the links to the pages that I'm going to show here, but I'm just going to pop out of, no, not do that. head to the browser, and I got the window open here. I had the window open here with all of the pages pre-opened, so this will be really easy. No, I just accidentally switched to the wrong desktop. That was just a little panic for a moment. Okay, right. Let's start with this one, Salesforce. Okay, subscription API management. So Salesforce, it's a CRM product. Your boss comes to you and says, hey, could you call our Salesforce thing and go get all of the opportunities and leads out of it because we want to integrate it into our in-house type system that we have? I was like, okay, let's go browse the API. Well, there's a Lightning platform. Lightning platform with SOAP. No. Okay, metadata API, marketing cloud API. Oh, Einstein something or other. Bulk, Connect Streaming, Tableau, tooling. I'm pretty sure a developer didn't name most of these things. Pardot, Quip, I have no idea where to go look. This is what we're talking about when we say discovery of APIs. I've got to discover which is the right API to go to. Let's not stick on Salesforce, because we all are guilty of this. Google, oh, cool. Google APIs. Here's the list. Oh, it's a big, long list. And when you add new versions, well, there's more APIs. And interestingly, if you dig into some of these APIs are differentiated by the first path segment. If you go in the Books API, that's /books. Some of them, if you go to the analytics, it's in the first part, the host name of the authority. So they have a hierarchy. They decided to create a hierarchy, but then they didn't present that hierarchy within the developer documentation. And when you allow teams to add APIs like this, it's like a team comes up with an API, they go, hey, I have a new API, there you go, put it on the list. There's no governance within the organization to go, yeah, how does this relate to other APIs? Is there a way that we could put these things together? We spend a lot of time at Microsoft when new features go into the Microsoft Graph trying to figure out what is the right place to put that new piece of functionality within the scope of all of the capabilities within the API. Having it just kind of this flat list, it takes away a little bit of that. But you know, we're not the only one. This is Azure. Azure has a really long list of APIs, very helpfully sorted alphabetically. So if I'm looking for databases, I better know that Cosmos DB is one option, MariaDB is another option, MySQL is another option, SQL Server is another option. There's better ways that these could be classified. And this is just finding the API. Now I want to go find the SDKs. Okay, cool. Over to Azure SDKs. There's an awesome team of folks over there building just a ton of SDKs. I happen to click and filter by the Java ones. For just Java, there are 1,181 packages. It has advantages splitting them into small things, right? I can just pick and choose the one that I want, and I only get a small package. But I got to find it first, right? And this isn't just a big company problem. If we go to Twilio, look, they support a whole bunch of different languages on their server side, and on the client side, they've got JavaScript and iOS. It's cool, but they've got 6 different APIs here. When they add a new API, that's 10 more SDKs that they got to go build, package, ship, and we have to discover. So it multiplies quickly. Let's go look at Docs. Stripe. We all hold Stripe up as like, these guys have awesome API documentation. And it's nice, it signs in, it customizes the documentation based on the version you're using. They do all kinds of cool things. They are a great set of documentation. Got a list of core resources. They're resource-oriented. When we go here, we look at balance, get endpoints, V1 balance, okay. I'm not sure what happens when we release V2, but okay, cool. Balance. And if you go through these, yep, they all kind of charges, customers, blah, 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 blah. Bank accounts. Wait, what? Bank accounts. V1 customer sources. Okay, you just taught me a pattern that the resources match the URI that I have to call, and then you just threw that pattern away. Well, it's because you see credit cards also are a different type of source. So we did something different here. But why did we do something different here? Did we decide that sources was a really bad name? Well, why didn't we go fix the API? Don't let them diverge like this. You're just causing customer pain. Plaid. There's another one where most of the resources match the table of contents, looking at transactions, looking at balances. Okay, well, that one's under accounts. We don't have it, so it doesn't quite match the hierarchy. And then if I head down to this income, it just goes right off the rails because income now is under credit, and there's creating a user underneath here. Now, probably because somebody decided, hey, we should be more scenario-oriented, task-oriented. That's a useful way of doing documentation. And it absolutely is in scenario-oriented documentation. In your reference documentation, when I want to go look up about how to make a call to an API, I want to be able to look it up based on that path that I know that I'm calling. Because the developer spent a whole bunch of time crafting and designing that API shape. This poor developer, I just feel for this person, where they created this, you know, they've designed their nice path, projects, project locations, custom jobs, that's cool. They go to put it in the API documentation, and their API documentation people, and I've had UX people come to me, oh, when you have a table of contents, you should never go more than 2 layers deep. It's bad UX to go more than 2 levels of nesting. Well, it might be bad UX, except for when I'm looking for something in a hierarchy that is nested more than 2 layers deep, like as a developer. So what this person did is they said, okay, well, we'll just go, you know, project.locations.custom jobs, and they stuffed the path in a different thing inside the table of contents. It's not ideal. You're familiar with Swagger UI? Look at this, the de facto pet store API. It's cool, and they did the right thing. They put pet, and they grouped all of the pet things together, and they grouped all the store things together, and they grouped all the user things together. Do you know how they grouped those together? Not using the first path segment. They had to go and create tags. Because we specifically in OpenAPI provide a way to create a hierarchy that is different than the path hierarchy that you designed for your API. And then when the person came to do this OpenAPI description, they went, oh, well, I'm just going to create tags that match the resource hierarchy. Why not just do it that way in the first place? I probably shouldn't go into this one. You know, there's some good stuff in Salesforce. This one happens to be create an order. You go and call the method called composite, and it took them 56 versions to come up with that name. Sorry, that was me. And just point back at ourselves. This is the Microsoft Graph API. This is the URL /print, printers, create. Why, there's a create method, the create thing there. Sorry. It's even worse than I thought it was. But it's under the hierarchy device and app management cloud printing. Like, that hierarchy doesn't match that hierarchy. Silly. It's like we're making our lives for developers more difficult. Just took a little bit SDKs. We take our description of our API, we project out to SDKs, and I don't know whether this is my browser, but it really doesn't like laying out those methods that are on the right-hand side, but this is some client that has been generated, and it's now created all of these methods where it's just munged the entire path and created it into a procedure name with the HB method as verb on the front of it. Right? We build this hierarchy, and then we throw it right away when we try and create the artifacts for developer experience. The Plaid API in Java has a new interesting challenge, is because they emit a class that represents the API, and they emit a bunch of methods. Again, they take each and every URL and flatten it into a name. Now, in this case, they didn't mess around with it. They just took the slashes out of it. So, like, you can sort of see the hierarchy in there. But then it's like, what are you going to do when this API gets really big? That class is just going to get bigger and bigger and bigger and bigger. Interestingly, if you look at Swagger code, Jen, they split the API, the clients out based on, guess what? On tag. So they have it split by, sort of by the hierarchy, but not really by the hierarchy. They have it split by tag. But in this case, it effectively comes out to the same thing. So let me just do a little PowerPointy thing. So from this brief survey of popular API developer portals out there, we can see everyone has challenges of finding their way to organize APIs, API SDKs, API documentation. And I believe that that beautiful path hierarchy that you designed should shine through in all of those developer experiences. So I'm going to show you one thing that we work on at Microsoft for trying to do that in our SDKs. So this is kind of what most client libraries do these days. They take that path of category A of API and collections and items, and they flatten it into this list, and they put it in a file. And this works fine until you have a larger API or a deep hierarchy, because we have this in PowerShell, because it flattened the path, and that is not something that you want to hold your face and have to justify to a customer why you are generating that thing. So what are the alternatives? You can take that same hierarchy and design a hierarchy of classes that mirrors that resource hierarchy. Allow your IDE's autocomplete to allow you to explore that hierarchy and discover the resources that exist and the HTTP methods that are supported on each of those resources. And then you can scale, right? You can add additional APIs with different category API in there. And you don't need to have separate SDKs for each API. You can have one API, one SDK for the entire set of features, and only one SDK per language to manage. So there's no more multiplier effect when you add a new feature. You don't have to ship a bunch of new SDKs. And when you get that question, should we add it to the existing API or create a new one? The answer is up. Just add it to the existing API. It makes it easier to reuse concepts across APIs in strongly typed languages, and it helps you drive consistency across API teams. But while this solves some problems, it also creates some new ones. Again, from our own experience, Microsoft Graph has 22,000 operations. That can be a problem when you compile that all, even with the hierarchy. It ends up, our .NET one is about a 13 megabyte one. We don't quite know what to do with TypeScript at the moment because the TypeScript thing is like a 100 meg package. That obviously isn't going to work. But nobody uses all of Microsoft Graph. Most people don't use all of any API that they use. We should have tooling that can enable us to pick the parts of the API that you want to use. Well, you say, how is that different than just each team shipping SDK for the little pieces that they build? Right? It sounds like when we merged the API, we just created a new set of problems. Yeah, maybe. But as I say, consumers don't consume APIs with the same granularity that teams produce them. Teams produce functionality that work for a range of different customer scenarios, and each customer will only use a subset. The APIs tend to be partitioned functionally, not by customer segment. And you get the other problem. It's far more likely that a customer would use 30% of 3 different APIs than 100% of one. It's not always the case, right? If you're building a new Twitter client for the Twitter API, but we've already talked, like Twitter did not want people to going off and building new Twitter clients, right? That is not an encouraged pattern because it competes directly with Twitter's own client and it fragments that user experience. API providers want their ecosystem of partners to go build different things that they're not building. Now, assuming I'm one of these application builders that I want to build an app that's calling 3 different APIs, let's consider how we currently have to do it, right? We go, okay, I want to call Vonage API, I want to call Stripe, I want to call Microsoft Graph or Azure. Well, okay, does their API provide an SDK for me? Well, Stripe doesn't, but it's okay, third party does for PHP. Azure doesn't do PHP, boo. Did they put it in the package manager they want? How often do they release updates to your particular language? Does it have the features that you actually want? So, and then you've pulled out each of those SDKs, and they all work differently. They all have different auth mechanisms because they're built by different people. So to try and solve this problem, what we've done is we built yet another SDK generator because, you know, that's the solution to the problem, just create another one, right? But the idea here is Kyoto allows you to build your own clients. It's fast, scalable, supports a broad range of languages, or it will. But I'm not here to sell Kyoto. There are other client generators out there. The point that I'm trying to get across is we should change who creates the client library to be the API consumer, not the API producer, because they know what APIs they want to call. The way we do this is it's a little command line tool. It's cross-platform. You tell it where the open API is. You tell it what language you want. You tell it what class to go generate for you. And then we use a filter. And you say, yeah, go generate me based off this open API, but only pull down these paths that I care about. You always have your supported language. You get the same experience because the SDK, the general code is the same. You update it whenever you want to. You get just the resources that you need, and the experience is the same. And there's a little code example here. This is what would be emitted for in our PHP example. And we reuse components, the PHP League Authenticator. We have a request adapter that adapts around Guzzle. And somebody yesterday suggested we should do a request adapter for Symfony client too. And then you just generate that client object, and you get an experience where I can now say client me messages, which is exactly the same shape as the path. But you get it in your programming language. So that's SDKs. This is Graph Explorer. It's our little tool. It's like Postman for exploring around Microsoft Graph and learning it. We put a little tree view in the corner, allow you to explore the graph like a hierarchy. I wish I could show you documentation examples, but we've seen these examples before. And I just want to reiterate, like, if you built the path structure once and design the hierarchy, don't design a different one. We are in the process of trying to build a doc generator that will generate from the URI structure. Interestingly, when I was going through the API platform screencast, it's like, oh, you already allow you to return documentation from the same URL. That's the point. Docs come from a website that is HTTP. Your API is HTTP. Why end up creating two different sets of paths to your API and your docs? Now all you need is a table of contents that allows you to go discover those docs pages. So using those paths has, in your developer experiences, can really help your developers progressively discover it in their own native languages. It can help you structure documentation so you don't run into these problems where it's one way in your table of contents and a different way in your actual API. And you can get away from structuring your APIs to be like the shape of your organization. Structure them in the way that makes the most sense for your customer. Ship value, not your org chart. And the most important message I can give you is consumers matter more for successful APIs. HTTP APIs are about distributed reuse. If you've only got one client ever calling that API, it's just a missed opportunity. Any work that you do as an API provider to make the life of your consumers easier is value that's multiplied by the number of consumers that you have, and that is the power of APIs.
Daryl Miller, everyone. Thank you so much.